Topic 9-3, referenced in our Holt textbook, Chapter 9, Section 1, on page 589 through 590. This is all talking about parallelograms. So recall that a parallelogram is a quadrilateral in which the opposite sides are parallel. I have a little diagram here that I'm going to show you to figure out area, and that's using a parallelogram that I've cut so that we can kind of see about how it's the same. We have several things in a parallelogram. This side is parallel to this side, and this side is parallel to this side. If you were to cut the parallelogram into a perpendicular anywhere along the bases, this is a base and this could be considered a base. And if I make a perpendicular line, I create my height. Well, what we've previously learned is that a rectangle has an area of its base times its height, or length times its width, which is the same thing. I can take that portion that I've cut a perpendicular and it forms a rectangle where you would have your width and your length. So you're going to discover that a parallelogram has a similar formula with lengths and widths. It's just that we use the height of our parallelogram, which will always form a perpendicular line. Don't be mistaken and put this as your height measurement. It's always going to form a perpendicular line. Okay, so if we plot the coordinates points below, P, O, R, and T on the coordinate plane, if we plot them and connect them as they say, what kind of figure would points O, R, S form? Well, I've already plotted it here, and the first ones are represented with your O, your R, and your S. Alright, we know that that actually makes up a right triangle because this and this form a box perpendicular. If you translate this right triangle 6 units to the left, that would be moving 1, 2, 3, 4, 5, 6. That's why this is shown as R asterisk. That shows this dot right here. And then 6 units with the S makes this the point for S asterisk, and likely corresponding with O asterisk. Alright, so this right here, what type of quadrilateral have you formed if you've taken it away from here and added it over there, just like I showed with my blue index card? And that would be a rectangle. So therefore, in a rectangle, your length is the same as your base of a parallelogram, and your width is the same as the height of a parallelogram. So the area of this figure is the number of square units in the interior of the object. So if we were going to determine the area now, you've got 4 units by 6 units, which would give you an area of 24 square units. And so thinking that the area of the original parallelogram and the rectangle that compares to it is that they are equal. So cut a piece out of a index card if you want for reference and make your own. But again, we can refer back to our parallelogram that we formed, and let's just put in the labels. You actually, on this one, you can form, if it's 2 sets of parallel lines, this is base 2 with this base 2. This is base 1 with this base 1. So label accordingly. Notice that they show this with 2 arrows parallel to base 1 with 2 arrows. So the bases can be formed by the 4 sides. The altitude, I haven't introduced that word, but it's actually the same as height. This measurement right here is referred to as altitude, but it's interchangeable with the word for height. So that's your altitude. It's the segment perpendicular to whichever base that you're asked to look at. Now, if you were asked to look at the altitude from these 2 bases, then this one would be your altitude. It formed the perpendicular line. So it does matter in answering problems as to which would be your bases. Okay, so the area of a parallelogram is equal to the product of the base and the height. So shortened, you could say that the area is equal to B times H. To find the perimeter of a parallelogram, simply add up all the sides. So we don't say 2 of our lengths and 2 of our widths for this one. You just are having to label all your sides differently. Okay, look at the first one. If you were to ask for the base, it's 10. The height is 4. And the area is this times that. Don't use the 8. It's using 4 times 10. It'd be like taking this triangle and moving it over here. You still have a 4 for the height, or if you change it to a rectangle, for the width. So be real careful. We're not using the 8. Now where we do use the 8 is the perimeter. The area is this times this, 40, but the perimeter would be a 10, a 10, an 8, and an 8. So 20 and 16 is 36 for perimeter. All right, here they've actually drawn in your height measurement. So 4 being my height, 12 being my base, multiplied together, these two amounts, you get 48. Perimeter would be 12 and 12, which is 24, plus 4 and 4 more, which would be 34. Actually, that's 30. Oh, I'm sorry. Don't, not the 4, the 5. See, even I messed up. Here you do use the 5 for perimeter. 5 and 5 is 10, and 10 and 24 is 34. So you are using the slanted parallel lines for perimeter, not for area. Okay, next one. This one, they're using a 45, 45, 90 triangle. So to review, you might want to make sure you have your 45, 45, 90. Actually, I think I'll draw it. Remember, it's always from a square. Just to see this separately. If this is my 90 and this is my 45, 45, they've given us that this is 8. So if 8 is equal to x square root of 2, that's what I'm doing. It's equal to x square root of 2. Well, I'm going to multiply again by a product of 1 on both sides. It goes away over here so that x is equal to, remember this becomes 2, 8 square roots of 2, but this reduces to 4. So 4 square roots of 2 happens to be this side right here. 4 square roots of 2. So that's my height measurement, and my base measurement was 10. So 10 times 4 square roots of 2 is 40 square roots of 2 for area. And for the perimeter, you're going to walk around, so you've got 2 10s, and be real careful, this time you're using 8. So 8 and 8, 10 and 10. That's where we get 36. Okay, here's a 30, 60, 90. I drew this one also, and you can always refer to your reference material chart, second page. Make sure you know the values of the sides across from a 30, 60 triangle. And that way we can take the values here. If 2x is equal to 3, then x is 1.5. Because you would divide 2 by both sides and you're going to get 3 halves. We just change that to a decimal. So either 3 halves square roots of 3 is going to be our height measurement, because remember this is my height measurement. If you remember and highlight, that's the same as what that was. So the 1.5 square roots of 3 becomes our height. So height times the base, these two multiplied together give us our area. Although our perimeter, remember again, you're using this whole side 6, and 6 is 12. 3 and 3, another 6 is 18. Okay. This one you really just need to use a formula. If the area of a parallelogram is 456 and the base is 24 centimeters, find its height. Well, you're just taking the formula and substituting in. This was my area, this was my base, and height is what I'm looking for, so I would divide 24 by both sides and get 19. And that concludes 9-2.